Hello everyone. In this lesson, we are going to use the first derivative test to find maximum area or minimum cost. In any optimization problems, we are given a given function and we have an objective function. So we'll divide into two parts. Left, we're going to write the given function. The given function is the perimeter. I get it from the total fencing that the farmer wants to use. So the farmer wants to put fencing around the rectangular field. The rectangular field has the front as the river and three sides. We can call it X, Y, and X. So the perimeter of the total material we're going to use is 2X plus Y equals to 2,400 feet. That is the equation given. To find the largest area, we need the objective equation, which is the area equation. Area equals base times height, so X times Y. Now, in order to get the maximum value, we take the derivative. In order to take the derivative of the area, we need to write this function in terms of one variable X only. So let's go and solve for Y. So Y equals 2,400 minus 2X. Now we're ready to substitute the Y into the equation of area. So we need to write area in terms of X. Area in terms of X is going to be X times 2,400 minus 2X. Using distribution, we get 2,400X minus 2X squared. Now we're ready to take the derivative. Remember, in order to take the derivative, we need to write our objective function that we want to maximize in terms of one variable, and we choose X to be the variable. We could easily choose Y. It would come out to be the same answer. So now we are going to take the derivative. A prime of X equals 2,400 minus 4X. So 4X equals 2,400. X equals to 1,600. Now we draw the first derivative test number line. That's A prime of X. And our critical point is 600. We are going to test to see what happened before 600 and after 600. We can use A prime of 500. And when we plug that in, we will get 4 times 500 is 2,000. 2,400 minus 2,000 is 400. That's going to be positive. And after 600, we can use A prime of 700, and we will get a negative answer. So we will write before 600 is positive, and after 600 is negative. So 600 is going to be the maximum because our function is increasing, that is positive slope, and it's decreasing after 600. So we say X equal to 600 is a relative max. To find the absolute max, we must check the endpoints. The endpoints are 0 and 1,200. When X is 0, then we're using everything for Y, all the fencing for Y. So Y is 2,400, X equals to 0. Then A of 0 equal to 0. And if we're using, let's go over here and check for the other endpoint, it's when X is 1,200. So since X is 1,200, then we have all the fencing is used for X. So X plus X is 2,400 and Y is 0. So we have 0 times 2,400 for 2X. That's also equal to 0. So we know the maximum area. So let's go and write the maximum area. Should be at X equal to 600 feet deep, and Y should be 1,200 feet. The reason is because when we substitute in 2 times 600, we get 1,200, and subtract both sides, so Y should equals to 1,200. So again, largest area happens at 600 for X and 1,200 for Y equals 720,000 square feet. In example number 2, we have a cylindrical can that can hold 1 liter. So here's our cylindrical can. And the volume is pi r squared times h, and that can hold 1 liter. 1 liter equals to 1,000 milliliter, which is the same as 1,000 cubic centimeters. So our volume equals pi r squared times h equals to 1,000 centimeters cubed. And the objective is to minimize the cost. So we want to find the dimensions or the radius and the height such that the cost is at minimum. So our objective function is the cost of the material. So our objective function would be the surface area, because the surface area is made of 2 circles plus a rectangular wall. If we unfold the wall, we're going to get a rectangle which has the base 2 pi r and the height is h. And now the radius of each circle is going to be pi r squared. So the objective is to minimize the cost involving the surface area. So let's write the objective equation. Our objective equation, surface area, is going to be 2 circles, 2 pi r squared, plus a rectangle. The area of the rectangle is 2 pi r times h, so 2 pi r times h. And we want to minimize the surface area to minimize the cost. Again, our surface area is 2 pi r squared plus 2 pi r times h. We must write our area in terms of radius. Since we have h, we go to the given function and we can solve for h in terms of r. So that's 1,000 divided by pi r squared. Now we take h and substitute in. So we have 2 pi r squared plus 2 pi r times 1,000 over pi r squared. Now let's just simplify and call surface area area. So when we simplify the area, we're going to get a in terms of r equals to 2 pi r squared plus 2,000 over r, because we can cancel the pi r with the pi r squared. Now let's rewrite this as 2 pi r squared plus 2,000 r to the negative 1. We take the derivative to find a critical point where there is a minimum or maximum. So we have 2 pi times 2r plus negative 2,000 r to the negative 2. And that is 4 pi r minus 2,000 over r squared. And when we set it equal to 0 to find a critical number, we get 2,000 over r squared equals to 4 pi r. When we cross multiply, we're going to get r to the third equals to 2,000 divided by 4 pi, which is 500 over pi. So our critical point, r radius, is going to be the cube root of 500 over pi. Now we take the second derivative, r double prime, to find out whether our critical point is a max or min. So we take a double prime and we get the derivative of 4r pi is 4 pi, and the derivative of negative 2,000 r to the negative 2 is going to be positive 2 times 2,000 r to the negative 3. So let's write it here. We're going to get 4 pi plus 4,000 over r to the third. Now we substitute the critical point into a double prime, and we get a double prime of q root of 500 over pi equals 4 pi plus 4,000 over 500 over pi, which is greater than 0. Since a double prime at the critical point is greater than 0, we know that the function is concave up. So r equals to the q root of 500 over pi is a minimum. Now I would like you to find the height, h, that will minimize the cost. Good luck on your homework, and I will see you in the next video.